What I did is I started with an assumption that we had a 60 amp load and then walked through the conditions of use. So when we started the calculations, when we first did table 31015B16, you started with a 4AWG 60 degree conductor or a 6AWG 90 degree conductor. By the time we went through the conditions of use for temperature, conductors in a raceway, heat ambience, all those kind of things, you would have required to be using a 2AWG 60 degree conductor or a 4AWG 90. So again, it shows, and there's a substantial difference between the two. 2AWG copper conductor for 60 has an ampacity of 95 amps, but the ones we originally started with had 70 amps. So we actually had to require a conductor that had 25 more amps of ampacity allowance just to maintain that 60 degree C rating.
Chris, let's talk about lights, or luminaires, as they're listed in the National Electrical Code. They typically generate a lot of heat. How does that factor in here?
Well, this is another example of things you have to take into account when you're doing your installation. A lot of the luminaires that you have will sit there and say you need to use a 75 or 90 degree C conductor. Now, that's not only because of the temperature of the termination. That has to do with the temperature generated inside the terminal of the luminaire. So if you don't realize what you're doing and you pull a 75 degree C conductor and hook it to a luminaire that says 90 degree C conductors, you're going to damage the insulation and again possibly have fires, arc faults, shock hazards, things like that. So it's not just what's generated around the world, the ambience, it's actual equipment you need to take into account sometimes, and you need to follow the luminaires. That's a common miswiring condition for a luminaire.
All right, as we sit here today and talk about ampacity and why temperature is critical to understanding wiring methods and materials, there are other temperature considerations in the National Electrical Code beyond what we've talked about. Article 334, type NM cables, and Article 338, type SE cables, right?
Yeah. Type NM cables and SE cables, when they're installed indoors, follow the same requirements. These are the non-metallic sheath cables that you use mostly in residential installations. And the rate of heat dissipation is affected by what the medium is, as we stated. So if you have something around air, heat can dissipate a little bit more readily. In a lot of homes, these kind of conductors pass through insulation. So the thermal insulation, being an effective barrier to heat, is trying to keep these conductors warm. So the code requires NM cables and SE cables that are in contact with insulation to have a further derating applied to them. Section 33480 requires an adjustment if you have 2 or more NM cables passing through insulation without maintaining spacing. And there's a section of the code that says maintaining spacing is not separated the required distances or the necessary distances for 24 inches or more. So if you have these kind of conductors passing through insulation, type NM cables have to be derated. SE cable, if you're using it for indoor installation, if it goes in contact with insulation, you're required to derate it even if you had 1 conductor. So it's a little difference. NM cables has the 2 or more requirement, but SE cable is derated on a single conductor or a single cable. And you're required to use, on the SE cables, you're required to use the 60 degree C ampacity column of the table 31015B16. So here's another case where, even though you have 90 degree C conductors, you have to be moved over to the 60 degree C column. Now with SE conductors, another thing you need to know about conditions of use is if it's not in contact with insulation, you don't have to apply those deratings. So there's all kinds of little things you need to know. And then there's another one for NM cables if they're bundled passing through a hole that's drilled, which is common again in dwellings, drilled through, say, a sill plate. If you thermally insulate these conductors, and again, 2 or more of them pass through a hole in the steel plate and you're using thermal sealant, you have to derate those conductors as well. And that's regardless of the 24 inches. That's going through the 1.5 inch stud.
You are watching NEC Connect. This is the latest episode. My name is Butch Stearns of the Pulse Network. Chris Coache, Senior Electrical Engineer of the NFPA, is alongside. NEC Connect is a monthly webisode. It's tied into the larger community, necconnect.org. Click around, find out more about it. It's all dedicated in your go-to source for the National Electrical Code all around electrical safety.